Welcome to MacEwan. I'm Nathan Taylor, an instructor in the Department of Computer Science, and thanks for joining us for our virtual open house. I wish I could be with you in person. Steve Jobs, the founder of Apple Computer, once compared the computer to a bicycle for our minds. When you study computer science, you learn more than just how the parts of a bike fit together. Computer science is also about the places that bicycle can take you. Computation has become essential in the physical and life sciences, social sciences, and the humanities, and in particular, those fields use computing to analyze increasingly large and complex data sets. What does this process look like? Well, let's ask some questions about COVID-19 in Alberta by grabbing a freely available dataset from the City of Edmonton website. So what is this dataset? It's a text document, something that we could open in a word processor or maybe even a spreadsheet application. And notice that we have one line in this document for every confirmed COVID-19 case in Alberta. And for each case, there are various facts within a given line about the individual in question, such as the date the case was reported, what zone the patient is in, and their approximate age. So as computer scientists, we see this file not just containing data, but structured data. And it's this regular structure that allows computer scientists to write programs that filter and transform this data to answer questions that we might have about it. Let me show you what I mean. We'll be programming in something called awk, which is one of the languages you'll get to learn at MacEwan. Let's begin by writing a program in awk that simply tells us how many cases the dataset has within it. In other words, how many lines of entries are there in this text document. Okay, now since we're in Edmonton, let's build on this program by filtering out all the cases that weren't reported in the Edmonton zone. So this is a pretty simple program that we wrote from scratch. But often as computer scientists, we're tasked with modifying an existing program to do something new. So here we have the absolute case count in Alberta, but maybe we want the percentage. It's a simple matter to just divide the ratio of the cases we just computed by all the cases that we saw in our first program. Okay, next, maybe we'd like to do more than output just a single number as an answer. To compute the case percentage across all zones, we can introduce a new kind of data structure within our program to store the case counts for every zone as we see them in the input data set. Choosing the right data structure for your program is important, and you'll learn how to do that starting right from your first course in computer science. Let me make one final change to this program. Let's collate this data not by zone, but by date, which is the second column, and make sure that our output is sorted. This shows us how case counts ebb and flow over time. Now, what if we wanted a pictorial representation of this data, say a line chart? Are we going to have to write a whole new program to visualize this data? Well, the answer is no, and that's because of a fundamental concept in computer science called composition. So I have another program on my computer called GNUplot that knows how to draw line charts, but doesn't know anything about computing COVID case numbers. And of course, we just wrote a program with the opposite characteristics. It knows all about computing COVID case numbers, but not drawing charts. So we can compose these two smaller programs into a larger program by passing these data structures that we've been filtering and transforming between them. And I think we agree that the composition of these two smaller programs yields a more interesting program than the two of them individually. And we could keep going, right? If we generated a bunch of charts, maybe something over time, we could compose yet another program that maybe animates each chart into a final video, or serves the charts to people browsing on the web, but I think that's far enough to go for today. In these few minutes, we've only scratched the surface of what computer science can help you discover, no matter what area of study you're passionate about. So to see where else the bicycle of the mind can take you, I hope to see you in a future computer science course.